All right, on page 2 in part 3, you have a picture and you're asked to find the measure of angle FGI and the measure of arc GH. So what we're really testing here is if you understand the relationship between an inscribed angle and an intercepted arc. So if we look at angle FGI, this first one, I'm going to highlight that, measure of angle FGI, it's asking you for this inscribed angle. And we know that the arc measure is 18, so the inscribed angle is going to be half of that, which is 9. So 9 degrees. So that's the relationship we want to remember. The inscribed angle is half of the measure of the arc. So then in this next question, you're given the measure, or no, excuse me, you're given the inscribed angle, and you're asked to find the measure of this arc. So if this is 39, and we said that this inscribed angle is half the arc must be double that. So GH must be 39 times 2, which is, what, 78. So 78 degrees. All right, moving on to the next 3 questions. You're again asked to find the value of the variable. These were like some that we did on the front. So you're asked to find x and then z and then m. So in number 17, again, we have a diameter here. So we have an angle inscribed in a semicircle. So it's kind of like what we were just talking about with that inscribed angle. If the inscribed angle, RQS, is inscribed in the semicircle, then we know it has to be a right angle because the measure of that arc is 180 degrees. So this is a right angle. So 5x plus 8 must equal 90. All right, we could subtract 8 from both sides. Therefore, 5x must equal 82. And when we do that, I know that's kind of funny because we get a number that's not divisible by 5, but 82 divided by 5 is 16.4. So x is equal to 16.4 for that to be true. Okay, the next question, you're asked to find z. And this goes back to, again, what we learned about inscribed angles. And we said that when 2 inscribed angles intercept the same arc, those angles are congruent. So if you look at this angle FGH, that is going to be 4z plus 9 degrees, it intercepts this arc FH. Then if you look at the angle FJH, which is 5z, it intercepts the same arc. So those 2 angles have to be congruent to one another. So we know that 5z is equal to 4z plus 9 because they intercept the same arc. So we could subtract 4z from both sides, and we are left with z equals 9. Okay. Next question. This goes back to things being inscribed in a circle. We said that when there is a quadrilateral inscribed inside a circle, that's a tongue twister, that the opposite angles of the quadrilateral are supplementary. And remember, supplementary means that they add up or have a sum of 180 degrees. Okay. So if I look at this, I notice 3 angles are labeled. Angle F is not labeled. So angle H, I'm not going to use that one right now because I don't have like any other angle to add it with. But if I look at I and G, they're opposite each other. So that means their sum has to be 180. So 8m plus 10m equals 180. If we add those together, we get 18m equals 180, and then divide both sides by 18, m is equal to 10. All right, part 4. In part 4, use circle A to find each measure. So be careful here, none of these angles are inscribed. So this angle of 32 degrees is the same as this arc measure of 32 degrees. So in question 4, when it asks for the measure of arc DE, this is still just 32 degrees because this is not an inscribed angle, it's a central angle where the center of the circle is the vertex. So the measure of angle the measure of arc EBD, so I'm going to go from E to B to D. That's basically from E all the way around the circle to D, and it's everything except this part of the arc. So what I might do for that is instead of adding this major arc and these two minor arcs, I might just subtract. I know there's 360 degrees in a total circle, and if I subtract that measure of arc DE, what I'm left with should be everything else. So 360 minus 32. And that is 328. All right, so then the measure of angle CAB, well, let's see, we could figure that out. We know that this arc DE is congruent to this arc BC, so this has to also be 32 degrees. So we have another 32 degree angle. All right, then if we look at the next 3 questions, the measure of arc CBE, so from C to B to E. So I could either do 360 minus these 2 angles, or arcs rather, or I could figure out what this one is from E all the way around to B and add that up. And it doesn't really matter. I kind of like to label everything in my picture. So I might subtract 2 32s and a 65 from 360 to figure out that this has to be 231 degrees. So now when I find the measure of CBE, I can just add 231 and 32 and I get 263 degrees. Okay, measure of arc CBD. So CBD is going to be CBE plus another 32. So really, I could just take this and add 32 degrees to it. So 263 plus 32 is, 295. You could also just do 360 minus 65. And then lastly, the measure of arc CD is 65 degrees. That one was labeled for you on the diagram. All right, part 5, write the equation of a circle with a center at 4, -2 that passes through point 1, 5. So our center, so actually if we go back to the equation, we know it's x minus h in parentheses squared plus y minus k in parentheses squared is equal to the radius squared. And we know that our center is h comma k, and in this case we have to figure out the radius. So I would start this out by writing the first part of my equation, so x minus 4 in parentheses squared plus y minus -2, which is y plus 2, and set that equal to r squared. And in fact, we already know that that's going to be part of our answer. Then we could plug in this point for x and y. So I could do 1 minus 4 in parentheses squared plus 5 plus 2 in parentheses squared equals r squared. That becomes -3 squared plus 7 squared, and that becomes 9 plus 49. So when I add those together, 49 plus 9 is 58. All right, so to go back to when I write my final equation, it has to have all of this in it and then 58 for r squared. So I would write x minus 4 plus y plus 2 equals 58. That's my radius squared.